All right, let's dive right in. Today we're going to talk about the invisible engine that runs our entire digital world, software. If you think of all the physical computer parts, the hardware, as the body, well, software is the set of instructions that brings that body to life. It's the crucial link between us and our machines, and it powers literally everything we do.
I wanted to start with this quote because it just gets right to the heart of why IT is so important. We're not just fiddling with abstract code or machines, we're talking about technology that holds people's most precious memories and solves real human problems. As an IT support specialist, you're the one on the front lines, making sure that technology actually works for people when they need it most.
So let's get a clear definition down. What exactly is software? It's simple, really. Hardware is all the physical stuff you can actually touch: the screen, the keyboard, the chips inside. Software, on the other hand, is the collection of intangible instructions that tells all that physical stuff exactly what to do. It's the code behind everything, from your computer's operating system to your favorite app on your phone.
Now, to really appreciate the software we have today, you have to look back at how we first learned to even talk to computers. This is a story about a journey, really, a journey of constant innovation, figuring out how to make that conversation between humans and machines easier, faster, and way more powerful. It all started back in the 1950s with, believe it or not, punch cards. I mean, literal physical cards with holes punched in them. As you can imagine, it was painstakingly slow. The first big leap forward was assembly language, which used commands humans could actually read. But there was a big problem. It was tied to a specific CPU, the computer's brain. So a program for one computer just couldn't run on another. The real revolution came with compiled languages, thanks to pioneers like the incredible Admiral Grace Hopper. See, a compiler works like a universal translator. It takes human-like code and turns it into machine code that could run on many different CPUs. And that totally opened the door for the scripting languages we have today, which are translated in real time to automate all kinds of amazing, complex tasks.
And this perfectly shows a concept that is central to all of computing: abstraction. Abstraction is basically just the art of hiding the messy, complicated stuff. On the left, you can see the crazy-looking code it took just to get the words "Hello World" on a screen in an early language. And on the right, that's the modern way. One simple, intuitive line. We've built up layers and layers to handle all the complex details for us, which frees up developers to focus on building awesome things, not getting lost in the weeds.
Okay, so that gives you a little taste of how software is born. But for an IT pro, the real work actually starts after the code is written. So now we're going to shift gears and talk about the software lifecycle, the day-to-day journey that every single application takes on a computer from the second you install it to the moment you get rid of it.
The whole huge field of software management really boils down to these three core tasks. First, there's installation. That's all about getting your users the tools they need to do their job. Next up, and this one is super critical, is updating. Think of this as your first line of defense for security and performance. And finally, there's removal, which keeps your systems clean, secure, and running smoothly. Getting this cycle down is absolutely essential for any IT support role.
And how you do these tasks really depends on the operating system you're working with. In Windows, you're usually living in a graphical world, right? You double-click an installer file, you use a settings menu to uninstall things. But in the world of Linux, it's often done right from the command line. You'll type out a command like sudo apt install. And that little word sudo, that's super important. It stands for super user do, and it's basically how you tell the system, hey, I have permission to make these big changes. So different methods, but the same goal.
Okay, let's spend a second on updates, because I really can't overstate how important they are. The number one, absolute top reason to update is security. Hackers are always looking for bugs, little errors in the code, that they can exploit to sneak into a system. Updates patch those holes. But they also fix performance problems, add cool new features, and just make sure everything on your system plays nicely together. For an IT pro, getting updates rolled out on time should be a top priority.
Now, managing the software on one computer, that's pretty straightforward. But what happens when you're responsible for a whole company's worth of computers? You just can't do everything by hand. You've got to work smarter, not harder. And that brings us to a really powerful topic: automation.
This question right here is the whole reason automation is so vital in IT. Sure, installing an app on your own laptop takes a few minutes. But now imagine doing that 100 times, or 1,000 times. It would be a complete logistical nightmare, right? Well, that's the challenge of scale that every IT department faces. And automation, that's the elegant solution.
The answer is automation. which is really just using software to manage other software. And the main tool you're going to use to make it happen is a script. A script is just a small, focused program that's designed to do a specific, repetitive task all by itself. Basically, you solve a problem once by writing the script, and then you can let the computer run that solution for you over and over and over again.
So here are a few of the big players in the scripting world. On Windows systems, PowerShell is your go-to. It's built right in, and it's incredibly powerful for managing the system. Over in the Linux and Unix worlds, shell scripts are the versatile workhorse for just about everything. And then you have languages like Python, which are cross-platform, meaning they work anywhere and are perfect for more complex automation or digging through data. Each one has its own special strengths.
So what can you actually do with these scripts? Honestly, the possibilities are almost endless. You could write a script that automatically backs up all the critical company data every single night without you lifting a finger. You could automate the entire setup for a new employee's computer, installing all their software with a single command. You could change security permissions on thousands of files in an instant. This is how you go from helping one person at a time to helping the entire organization at once.
Yeah, this old line couldn't be more true when it comes to automation. The exact same script that can save you days of work managing 1,000 machines can also cause 1,000 problems in the blink of an eye if something goes wrong. This kind of power demands caution and precision and a whole lot of respect.
It's so important to understand the risks here. A script you download from some random website could easily have malware hidden inside, ready to spread across your whole network. A single tiny typo in a script could accidentally make sensitive company data public. Yikes! A poorly written script could even crash critical servers. The bottom line is this. Always test your scripts in a safe environment first. Understand exactly what every single line of code does. You have to be meticulous.
So, let's pull all of this together. What does this all mean for you, whether you're already in IT or just starting out? It means you play an absolutely vital, indispensable role in any organization today.
I want you to think of yourself as a steward, like a guardian of your organization's digital tools. You are the one entrusted with managing, maintaining, and securing the very software that everyone else depends on to do their jobs day in and day out.
And that stewardship really breaks down into these key responsibilities. You're the one who makes sure the software people need actually works. You are on the front line of cybersecurity, keeping everything patched and secure. You empower your coworkers by giving them the right tools. And you protect the whole organization by being the gatekeeper, stopping bad or unauthorized software from ever getting a foothold.
And that's really the big takeaway here. From recovering someone's irreplaceable family photos to automating critical tasks for a global company, software is the engine that drives our world. It's not just about code. It's about empowering people, securing information, and making things work. So the only real question left is, what part are you going to play in shaping it all? Thanks for joining me.